Welcome to Lesson 3, Angle Measures. Our objectives today are to find relationships from angle bisectors, also to identify and build algebraic equations from angle relationships, and finally to solve equations in order to find missing angles. This lesson we will be putting together all your knowledge and your skills related to angles in order to build those relationships and solve them to find the missing measures. All right, let's do a quick angle review. So if you'd like to pause the video and write these down in case you don't have these in your notes, now would be a really good time to do that. A couple of the key important ones are going to be vertical angles. And remember that vertical angles form a cross, and vertical angles are across from each other. So in this example, 1 and 2 are vertical angles, and they have the same measure. The angles on to the left and the right are also vertical measures, and all vertical measures are the same. And then we also have linear angles or linear pairs, and together the two angles make a straight angle. They make 180 degrees. So in this example, we have angle BCD and we have angle BCA. Together, those two angles, we know they sum to be 180 degrees. Complementary angles always sum to be 90 degrees. We know 4 and 5 are complementary. They are across from this box right here, this angle with the box, which we know represents 90 degrees. Together, these two make up a straight angle. So we know that 4 and 5 have to be 90 degrees. So together, those two are complementary. And then finally, we have down here supplementary angles. And that's two pairs of angles, very similar to a linear pair, that make up 180 degrees. The difference between supplementary angles and a linear pair is that a linear pair have to be together. They have to be connected on that same line, whereas supplementary angles can be separate. So in this case here, angle 6 could be over here, and I could write angle 7 over here. They don't have to be connected to form that straight line. But what we know is that angle 6 and angle 7 together, if you sum them, will come to 180. Okay, let's try our first example. Let's look at angle bisectors. An angle bisector is a ray which contains the vertex, and remember here is our vertex A, and divides an angle into two congruent angles. And I can tell these are congruent because of my congruency marks right here. That's one way to make congruency marks. Sometimes you'll just see the arc and you know those two angles are congruent. So here's what we need to know. Ray AD bisects angle BAT, this big angle, so that angle BAD, so we're talking about this angle in here, is congruent. Now this right here that looks like an equal sign with a little squiggly over the top means equal, but we say congruent. That means we don't actually know the value, but we know that it is congruent. We know that it's equal to angle DAT, this angle right here. So if you have an angle bisector, then you know that it bisects the large angle into two congruent or equal angles. Now let's practice that algebraically, see what that looks like. In this diagram, ray CD bisects angle ACE. So right away, a trick for you guys is to always draw these out and go ahead and put the marking in. So I'm going to put two congruency marks in here, meaning that this angle ACD, is congruent to angle DCE. So then they give us some information, and this M right here means the measure. So if the measure of angle ACD is 48, I'm going to go ahead and write 48 in here. What is the measure of angle DCE? So what is this? Well, based on our theorem, based on what we just learned, we know that it's congruent to 48. So we know that it's also going to be equal to 48. It's congruent. DCE is congruent to ACD. So those two will be the same. Let's try another example. So now we're just going to be identifying relationships, like I said, based on your skills and your knowledge of angles. We're going to write those relationships out algebraically, and then we will find the missing measures. So in this situation, we have angle cat and angle bat are linear pairs. Now there is no diagram, so what you need to do to be successful in solving this problem is to create a diagram. So what I'm going to do is create a straight angle, 180 degrees, and then I'm going to create these angles. So angle cat, so I can just do this, and I don't know which one of these is obtuse and which one is acute, but I'm just going to do a rough sketch. So here's my angle cat and angle bat. So here's BAT, this is an A, and CAT are linear pairs. I've created a set of linear pairs here. If the measure of cat is 3x plus 120, now they're giving me a measure, and I'm going to write that in just so I can visualize it, so I can see it. 3x plus 120. And angle bat is 5x minus 4. What are the measures of angle cat and angle, that's supposed to be bat, and angle bat? So what are they? How would I solve that? This is where writing your relationships is so important. If you can write the relationship out algebraically, you can solve it. So what did we say about linear pairs? We said that the combination of the two angles together is equal to 180 degrees. So I need to set up a relationship that shows that. Well, this angle is 3x plus 120, so I'm going to write 3x plus 120. And if I add it to my other one, which is 5x minus 4, I know that I'm going to get 180 degrees. There, I've set up my relationship. Now all I have to do is solve it to find the answer to this question. Well, if I'm going to solve it, I need to combine like terms. I've got a 3x and I've got a 5x. Those combine to give me 8x. And then I've got a 120 and a negative 4. Those are going to combine to give me a positive 116. All right, now I need to solve for x. So I have to subtract 116 from both sides. And I'm left with 8x on this side. These go away. Is equal to, and it looks like we have 64 over here if I subtract. And then if I divide both sides by 8, 8 divided by 8 is 1, or just 1x. X is 8. So have I solved this problem? Have I answered the question, what are the measures of angle cat and bat? Not quite yet. I figured out what x is, but I haven't actually answered the question yet. So I need to take my 8, and I need to plug it in here in place of x. And then I'll know what these angles are. And I really only need to do it in one, because I know the other one will add up to be 180. So I'm going to go ahead and try this one here. So I have 5 times 8 minus 4, so that's 40 minus 4. So I know that this angle here is 36 degrees. So if this angle is equal to 36 degrees, all I have to do is subtract 36 from 180, and I'll know what this angle is. I can also plug in the 8 into this equation as well, and I can solve. 8 times 3 is 24 plus 120, and that will give me an angle measure of 144 degrees. So either way will give me the answer, and I can check my work. 144 plus 36 should be 180, and it is. All right, that's one example. Let's try another different example. In this diagram, we have the measure of MRS is equal to 65. Now remember what I told you. Let's go ahead and fill that in. So this is 65. This one's a little more tricky. This requires you to think about things. So we want to find each of the following, the measure of angle MRZ, MRT, all these. So before I start doing that, what I'm going to do is I'm going to look at my diagram. I'm not going to answer these questions yet, but I'm going to fill in everything I know. Well, this one with the little square in here, remember that's a right angle and that's 90 degrees. Well, all of this line right here, this is a straight angle where I'm drawing in blue. So if that's a straight angle, then that means the 90 plus the 65 plus whatever this is should sum to be 180. So what I can do is I can take 90 plus 65 plus some number x has to sum to be 180, and then I can figure this out. So 155 plus x is 180. If I subtract 55 from both sides, or 155, then x will give me 25. It looks like 25 degrees. That's right, right? 7, yep. So now I have figured out 2 additional angles, and I still haven't looked at what I need to solve. Now let's look at a couple other things. We have a congruency mark here, and I'll highlight that in yellow. So we have a congruency mark here with this one. So we know those are vertical angles. So if this is 25, I know that this angle also has to be 25 degrees. Well, let's look for some more vertical angles, because vertical angles we know are congruent, so there's not a lot of calculations. Well, we've got this angle here in pink, which is a vertical angle to this angle here in pink. So this angle VRT is going to be congruent to angle ZRS. Well, I know what ZRS is if I just add the 90 and the 65, and I know that's 155. So look what I've done. I have filled in every single angle in this diagram before I've even answered the questions. And that's what you want to do, because sometimes you might not be able to find the measure of angle MRZ before you find the measure, say, of angle ZRV. And that holds true in this diagram. I had to first find the measure of angle SRT before I could find the measure of angle ZRV, or even VRT. So sometimes you just need to take the diagram, fill in what you know, and then go back and look at the questions. So the measure of angle MRZ, let's find that right here, is going to be 90 plus 25. Those 2 angles together give me 115. The measure of angle MRT, so that's MRT, are these 2 combined. So that's 90 degrees, and I already knew that because this and this are supplementary. Let's look for the measure of SRT. So we have SRT, we've already got that one filled out, that's 25. And then angle ZRV, we've also already got that one filled out, that's the vertical angle to SRT, and that's also 25. And then finally we have the measure of angle TRV, and that was 155 degrees. Okay, that concludes our lesson today on angle measures. So now hopefully at the end of this lesson, you are starting to understand how to find relationships. One of the key strategies that remember that you can use is to build a diagram if there's not already a diagram. The second key strategy is to fill in the information you're given into the diagram in order to better help you see those relationships. From those relationships, you will be able to build algebraic equations which you can solve in order to find those missing angle measures.